Hey everyone, welcome to Code Harmony. Today we are going to cover this problem, LeetCode 684, redundant connection. This is based out of graph theory, and here we will be learning concept of disjoint set union. Let's have a look on the problem statement. Let's see what is given in this paragraph. In this problem, a tree is an undirected graph that is connected and has no cycle. That is fine, we already know that. You are given a graph that started as a tree, okay, with n nodes labeled from 1 to n with one additional edge added. Okay, before we move ahead, let's say we are having 4 nodes. 1, 2, 3, 4. Is this a tree? Yes, this is a tree. This tree is having how many nodes? 4. 1 to 4. And how many edges? 1, 2, 3. 3 edges. It means 4 minus 1. N minus 1 edges are there. Okay. And they are saying that there is one additional edge. Okay. The edge and the added edge has 2 different vertices chosen 1 to n. Okay. In the new added edge, they have chosen 2 different vertices. Let's say the new edge is choosing these 2 vertices and connecting it. It means that it is causing a cycle. The new extra edge is causing a cycle. Otherwise, it is working fine. The graph is represented as an array of edges of length n. Edges are from A1 to B1. Indicates that the edge is between A1 to B1 in the graph. Okay. They have given the edges array of size n. Edges array of size n for n nodes, but instead we should have n minus 1 edges. N minus 1 edges are valid, but why n edge? It means there is one extra edge. That is something which should not be there. So what they are expecting us? They are expecting us to return an edge that can be removed so that the resulting graph is a tree of n nodes. Okay. So what edge we have to remove? In this case, we can directly see that, okay, we are going to remove this edge and we are then going to have n minus 1 edges, and this edge is removed and now it is a tree of n minus 1 nodes. Okay, so this is the problem statement. In short, the problem statement is saying that we are having n number of edges, and from these n number of edges, one edge is something that is causing a loop and that we have to remove so that we will have a valid tree. Okay, so this is the problem statement and this is the example. Let's say in this example, if we just remove this edge, this is an extra edge, redundant edge. The remaining nodes will form a tree, and now it is like a graph, or you can say have a cycle. So how do we proceed it further? So let me tell you, before we move ahead, we are going to solve this problem with disjoint set union data structure. Disjoint set union, or you can say unified. This data structure is a very important graph theory concept, graph theory essential, you can say. So you should definitely understand this question. And I have already prepared a video on disjoint set union. It's a very detailed video covering every basic thing. So if I just open it, you can just watch this video and get an understanding of disjoint set data structure, and then you can continue from here. Okay, now I assume that you have some understanding of disjoint set data structure. We already know that in disjoint set, if we are having n number of edges and the nodes are also n, it is given in the problem statement, nodes are also n, we usually require a parent array. Parent array of size n. 1, 2, 3, 4, 5. Let's say the indices are 0, 1, 2, 3, 4. Initially, these nodes are going to store the parent of every single node. Parent of 0th node. Nodes are from 1 to n. So let's assume that when we are dealing with the parent array, I will just do it I minus 1 or j minus 1. Initially, let's say all of these nodes are not connected. Okay. And nodes are getting connected using these edges given in these edges, and this edge is going to have n number of edges, but in actually we require n minus 1 edges to be able to make a valid tree. Otherwise, using an edge, it will make a graph which is having a cycle within tree is a graph. Okay, so from these n edges, n minus 1, we are going to choose one edge we are going to discard. What edge we are going to discard, we will see later on. For initially, both are unique component, both are belonging to different set, or you can say different disjoint set. If these are sets, then these sets are not getting overlapped. Okay, and we require one parent array, we have two major functions. One is find and one is union. Find is finding the parent, finding the root of that connected component. In this case, we are having 5 components. Root of 0th node is 1, or root of first node is 2. In this case, if we just ignore these nodes and I just make it value from 0 to 5, it will look like this: node 0, node 1, node 2, node 3, node 4, from 0 to 5. And these are the node value. Node value, I will just remove -1 from here. So it will be 0, 1. Okay. So these are the nodes, and initially the parent, what are the parent value they are having? Let me initialize it with -1. I always initialize it with -1, or you can do whatever you want to do. You can have the same value itself. It will just change the condition, checking condition when we have reached the parent or not. Okay, initially both are independent, and then we want to make it connected. To make it connected, first of all, let's try to add edges slowly. One edge is going to be from 1 to 2. It means that 1 and 2, initially they were having two disjoint sets, but now we have to make a union of these two sets. Union of these sets means both should have a single parent. Initially 1 is at here, 2 is at here, both are independent parents. So initially, let's say I'm making 1 as parent. It means 0 is the parent. So 1 will be updated to 0 here. 1 has a parent of 0 and 0 has a parent of -1 itself. So it will look like this. Now first edge is fine. First edge is working fine. We just did the union of two components. Two disjoint set were there and we just made the union. Okay. Let's come to the second edge. Second edge 2, 3. Connecting 2 and 3. What is the parent of 2? Parent of 2 is 2 itself. And what is the parent of? Parent of 2 is, parent 2 means edge number 1. Or let me do one thing. I'm just avoiding this conflict of making these different edges. Let me see that, okay, indices are starting from 1. Let's assume that indices are starting from 1. Index 1, 2, 3, 4, 5. Firstly, we connected 1 and 2. 1 and 2, parent of 2 is 1. So parent of 2 is updated to 1. And now 2 and 3 are connected. First of all, find the parent of 2. Parent of 2 is 1. Find the parent of 3. Parent of 3 is 3 itself. Both are different. It means they are from different sets. They are from disjoint sets. So just make the union of it. It means make anyone as a parent. Let me make 2 as a parent. Parent of 2 is 1, and this 1 will be the parent of 3. So 1 will be the parent of 3. So now the parent of 3 will be updated to 1. And now let's come to the next edge. Next edge is 3, 4. 3, 4. Parent of 3 is 1. 1 in this case. And parent of 4 is 4. So just combine it. Parent of 3 is 1. I'll just make the parent of 4 equal to 1. So the parent array will look like this. 2, 3, 4 and 1 are having parent common to 1. Now at this moment, the stage is something like this. These 4 are from one component and this is from different component. So the state is something like this. 5 is placed somewhere at the edges. This is the state. And now let's come to the next edge. Next edge is 1, 4. Now they are trying to join 1, 4. Okay. If we are joining 1, 4, we are forming a cycle. By the diagram, we can directly say that this is going to cause it a graph because cycle is being introduced and we have to keep maintaining the tree. But in the very large input, we can't directly say by seeing at it. So what we have to do is we are trying to merge 1 and 4 because this is the edge. First of all, find the parent of 1. Parent of 1 is 1. Find the parent of 4. Parent of 4 is 1. If both are having same parent, okay? If both are having same parent, it means they both are belonging from this one connected component. If they are from one connected component, there is no need of this edge. It means this edge is not required. If edge is not required, it means directly say that okay, this is the edge which is causing the issue. We were having n edges and n minus 1 edges are valid. We have found one edge which is not valid, so that is going to be my answer. So when you are doing the union of, let's say, two elements, and if those two elements are 1, 4, then you can directly return a boolean that okay, whether they are already from a same component or not. So you just have to modify your union operation. Find and union, this you have to do, and in this way you are going to approach. So what you have to do is, first of all you have to initialize a parent array, and in the parent array you have to keep union these components. And if at any moment, if you try to make a union of two edges, let's say edge A and edge B, and by any chance if those two edge are from a same disjoint same set, then you can't join those two sets, and it means that edge is something that you have to return. Okay, you understood it? I will show you the code. And now before that, what is the time and space complexity of this approach? If you have not understood my approach, I would recommend go to this disjoint set video, because I have seen the examples where people find the understanding of disjoint set very difficult. Let's come to the time and space complexity of this approach. Time is number of edges. We are going to every number of edge, and we are storing and we are combining using the help of parent array, and this parent array is our space. So the time and space complexity almost linear. Okay, now let's have a look on the code. If you have a look on the code, what I have done, I just created a union find data structure, and for every edge I am just making a union, and this union function I have prepared in such a way then when these two are having same parent, in that case it is going to return false. It means we are only joining two disjoint set when they both have different parent. If I am getting false, it will become true and I will return that edge. It will become false when it will not be joining these two nodes. It means that these two nodes are having same parent. Okay, so this is the whole concept, and this class is something that you need to understand. Union find class taking a data which is parent array. Parent array I have initialized it with -1 in the constructor. You can initialize it with the same value as well, but this is my style of doing it. This is find. Find is something until you find the parent. You find the parent, just keep on finding it further. And what is this that I'm doing right now? Parent of x is equal to x. There is something called path compression. So that to avoid time and to be able to find the parent efficiently, we are doing this. And this is union. Find the parent of both the nodes and then just join it. Parent of A is becoming equal to parent of B. So this is whole about union find, and it's a very efficient data structure to solve these kind of problem quite easily. Find connected components, find loop, find cycle in the graph, and this question as well. Okay, I hope you have understood it. I will just paste or attach the code in the description below. If you have any doubt, you can comment. Okay guys, bye bye.